Hello everyone, this is Eric from Exit Games. This will be an introductory video on Photon Quantum version 2. So this should be a good starting point for anyone onboarding into developing a game with Quantum for the first time. So let's start with the very basics here, which is you go to the website, documentation website. If you see here on the right in the menu, you have this SDK and release notes section of the website docs. And first thing you have to do is always try to get the latest possible SDK when working with Quantum. You see that you can always upgrade from, if you start with a version and then we get a new, more stable version, you can always upgrade from that one. But until we get, let's say, a stable version out, which is recommended for going into production, the best suggestion is always to get the latest nightly build on our most recent release candidate. So as of today, this will be build 536 on RC release candidate 2. So just get this one. I already did, so I already downloaded this zip file, and I'm going to show what you get. So when you download, you get the zip file, you uncompress it, and you get this folder structure, which is something interesting because Quantum is a game engine. You normally start developing the game from scratch with the basic folder structure we give you, which contains one folder for a Visual Studio solution for the simulation part of the game, like your gameplay built on top of the Quantum game engine APIs, and a folder with a skeleton Unity project that you can just open on Unity. With Quantum 2, this means Unity 2018 4 or up, anything up to the latest version. It is technically possible to, let's say, bring Quantum to an existing project, but this is a bit more complicated and we do not officially support that. It is, if you have a lot of experience with Unity, you can do it after you understand how Quantum works, but we always recommend you start at least with your prototyping with the recommended way, which is starting from these skeleton projects. You can always bring in your assets in and your visual stuff in, as is demonstrated in several videos and other stuff, but this is the best way to start. Okay, so I read the two things here. So one, I already have opened the Visual Studio solution. In my case, I opened it in Rider, but we're not going to start with coding. With Quantum 2, it is actually much easier to get your first hello entities thing directly from Unity. So I have the project open here on Unity, and one of the things you should already notice, besides the project structure here that we can talk about a bit, but it's not really important right now, is that we add this menu option here to let you select between the scenes, the Unity scenes that are part of the build. So, and with the initial project, we already supply you with a menu scene that lets you quickly go online, but you actually start developing the game with what will be the gameplay scene, and that's all set up already with the minimum Quantum requirements for including, and that includes the script that actually runs the Quantum simulation, a script to control the views, because if you're new to Quantum, Quantum is a game engine with an ECS, Entity Component System, in that the simulation is done via entities and systems. And Unity, and these are all independent from Unity, and Unity itself acts as a view only, so it will be used only to render these objects on the scene. So this script here will help, will do that automatically to you, and a few other important scripts here. But the thing is that because Quantum supports both multiplayer, local multiplayer, single player, and online multiplayer, it's super easy to test. If you just press play on the scene, you already have the game running. So this is running. Of course, we didn't add anything to it, so there is no no entity, nothing being simulated, but you already have a few statistics here with this object that help you see the health of the application. So you see how much memory our internal heaps are consuming and that kind of thing. So let's start doing something meaningful here. So we also added a few context menus that help you go do a very, very quick start on how to add things to the game. So I'll do two things here. I'll start adding. So let's do something physics based. So there are two ways in the context menu here, two different kinds of things you can add to the quantum simulation in terms of physics. You can have static colliders. Static colliders are interesting because they're much, much cheaper to run, but the drawback is that they cannot move. So you cannot move them around, but they're super good for levels. We support terrain collider, we support mesh collider, and other kind of things. But let's say our skeleton objects here, you have easier way to add like a box static collider. So I just added this guy to the origin here. Let's scale it a bit to make something like a floor to us. So let's scale it to 10 by 10 on the XZ axis. And that's it. You have a quantum static box collider that we'll call a floor. And this is already part of the physics simulation. And second thing we can add is we can add a quantum entity directly to the scene. So I'll add what will be a box entity. Let's keep it with the standard 1:1 size. Let's also move the camera to align with what we have here. So on the game scene, we'll also see the same. So this is interesting because it has a Unity game object here that lets you create what we call an entity prototype in Quantum. Not only an entity prototype, but a special kind of entity prototype that belongs to the scene, so it will be automatically instantiated and will be there as you press play. So it's as easy as this. But this, when you add an entity, like one of these prototype entities, it does come with a physics collider, as you see here. So this is the quantum-specific physics collider. It's all set to match exactly the size of the entity you have. But if you want it to be controlled by physics, you also need to have a physics body. So this is what I'm going to enable here. I'm going to make it be a physics body. And you have all sorts of options here. So you can make it be kinematic, you can make it, you can control how it is awakened by forces or other things, but I'll just keep everything default. The options like rotation freeze, resting, and so on, but I'll just keep everything default here. Mass 1, so that will be the mass of the object, of this entity, and so on. You see that we have other standard components like nav mesh based pathfinding, steering, and collision avoidance, but you'll also be able to add custom components that we'll get to this point in a few minutes. But this, just by having a physics body here, is enough to run. So if we press play now, you see that the box falls because there is probably some gravity going on. I will make something more interesting here by adding a rotation to this object in the scene, which will become an entity in quantum jargon. And if we press play, you see collisions are computed correctly, it is simulated correctly in terms of physics collisions. So that's, let's say, a physics hello world. You already have quantum running, and you have a basic physics object going on. You can a few interesting things you can do here. So you can make this box entity a Unity prefab, and then you see that it creates two sub-objects here that call the entity prototype and the entity view. This is well explained in the documentation that I'm going to show you guys in a few seconds, but this should be enough. So it lets you fully leverage the idea of Unity prefabs. So if you duplicate this object, it will automatically be a copy of the Unity prefab. So any modifications you do directly on the prefab here will be reflected on the copies that you have on the scene. So I'll just press play again here, and now we have two copies of this entity being simulated. So to understand better what you can do with entity prototypes and what they mean, and how you can have entity prototypes with view, without view, how you instantiate entity prototypes directly from the scene like we're doing here, or by code, as we'll get soon to it, I suggest you guys to take a look at the manual pages, and there is an entry called entity prototypes. So if you click there, you have all this explanation about what these things mean, and what you can do with them, and so on. But this is the main the simplest way to get something running. But let's say you want to add a character, you want to add something that moves around and so on. So let's create a new a new entity in Quantum, but I'll do something different here. I'll create an empty entity, an entity that will have, I'll set it to use a 3D transform, so it will have a 3D transform, but we do not have yet any visuals to it. It's just an empty entity here in the Unity world. And what I'll do here, I'll add a capsule kind of, or maybe I'll just add a cube, a Unity cube. But the thing about this Unity cube is that it will not have any meaning to the simulation. I'll just make it be just a visual thing that lives inside this container for the entity. So this entity is here, and I'll make the view for this guy be, I want to reduce its size here in one of the axes, so something like 0.5. And if we add the gizmos here, we see that this entity also has, so let me remove this guy so we see here. So the entity itself does not even have a physics collider yet, but I'm about to change that. So let's make this entity has a physics collider. We'll choose the box type, and we'll decide the extents, which is different than size. So let's see, on the y-axis is going to be 25, here is going to be 0.5, and here is going to be 0.25. So this is just a collider, so it's not really, it's not a dynamic body for the entity itself. You'll see that it matches our cube, our visual for the cube, fine. But the thing is, we'll not add a dynamic body. This is going to be a character. We normally do not control characters with dynamic bodies. So what I'll do here instead is I'm going to add another standard component Quantum comes with called CharacterController. And when I add a character controller to Quantum, it is added as a separate Unity script here, but you don't have to change anything here, because even this drag and droppable configuration asset here that I will talk about in a few minutes is not strictly required, as it will pick up the default one if you do not pass one. But just to do like you should, I'll drag and drop it here. So we already have these standard configurations here. So it's interesting because you can set a few things about the character controller, and you already have an interesting relation here. So in Quantum, the character controller is not like a collider or a rigid body in Unity. So what it does, it is a query-based mechanism for you to resemble how the character moves around. And the best way I can describe this is it should resemble what your feet area are for a character, for a biped character, for example. So it does not have to match actually the collider of the character. The collider is like, let's say, the body of the character that others cannot go through. So the other character's character controller or other objects will not penetrate the character collider. But the character controller itself, in Quantum, it normally is configured to resemble the feet. So when you press play, here the gizmos should show the character controller area around, and you see that it's a bit it's offset. It's not it's around the center of what the character is, and that's what I want to change here. So I'm going to make it slightly smaller. So I'm going to make the radius be 0.25, and because of that, I'm gonna make it be slightly dislocated, so it becomes around what the feet area of the character is. So we can tweak these values here, but this should be enough. Maybe I'll make it a bit bigger here. So something like 4 should be enough, or so this should be fine for it to move around safely. Because I made it that size, I think I can make it so yeah, that will make it touch exactly where it fit is. So this should be fine. I cannot save it, but sorry. But one interesting thing that you notice here is this guy's not moving. So although the configuration for character controller here in the bottom shows that you do have a gravity, this guy is not moving, he's not falling. So what happened here? So the thing is that when you start going all the way to having character controllers, you have to start coding. So we need to do something. So now with code. But before we get into coding, let me show you where you get more information about this. So I'll suggest you a couple of things to take a look at before when you go for moving that. So there is an entry point in the menu in the subsection Quantum ECS about systems, where you write game logic. So you understand how you can create logic by creating systems in Quantum. So there are several different kinds of systems, like regular main thread systems. You can have a system for filtering special kinds of entities that have certain components, so you can already have a simplified update for each one of the entities. But we give you full flexibility on how to do. You can have systems only to deal with callbacks and so on. So I recommend you guys reading this entry on systems here. And also the entry on components will explain you how you can filter entities and loop through them in several different ways that will let you do whatever you want. It doesn't have to be components you create, it could be even the standard components Quantum have. And the last entry that will be interesting for what we're about to do now will be in the full menu about physics, there is a specific entry about the kinematic character controller code and how you make the best use of it. So I'll just make the most basic possible thing here, but you have more full documentation here on the website. So we have this guy here, but it is not moving. So let's fix that, and we'll go to coding here. So there are a few interesting things here. So the standard solution already comes with the preset with the DLL dependencies. A few important things. The simulation is 100% agnostic from Unity APIs or code. So this is, you see that we code the gameplay completely on Quantum Physics Engine, Quantum Navigation Systems, Quantum ECS. There is nothing directly related to Unity here. So Unity is used to do the level design and create the data that will be used to run the simulation here, but you do not actually run through any Unity code from here. And this is very important because it lets you run simulation outside of Unity for testing. It lets you run simulation outside of Unity on our servers without relying on any licensing or any Unity headless instance that would be expensive to run on servers, etc. So it's a very convenient and lean approach. So it comes with a lot of basic things here. I'll not explain every single one of those in this video. There are documentation entries that go deeper in each one of these, so I'll focus on just two things for now. We'll create a system to update entities that have a character controller, and we'll do this using a special kind of system called system main thread filter, which is, let's say, the most common system that you guys will probably be using. And we will create one basic DSL file to declare one single component type and define our input data structure, our basic input data structure here. So this is all I'm going to cover here. So let's start with a basic system to make the character move. But to make the character move, we have to have some kind of of input for the player to be able to move the character with. So in Quantum, I'll go ahead and create a folder here first. So let's call it demo. So in Quantum, we have this special kind of file called QTN file that lets you specify structs, components, and a few other things that will comprise what we call the game state. And these will be code generated by Quantum's compiler. And the documentation entry that explains these files is in here in the Quantum ECS part DSL. So this is another one that I recommend you guys reading, so you can define a lot of stuff. The basic stuff would be components and input, and this is the one we're going to start with because it's the only one we need to have something for the player to tell the simulation. So this is as simple as creating an entry called input, and I'm expanding the font here. Add a scope to it, and you define what kind of data your input is. So we have a special button called a special data type called button that lets you create this, and this will be super convenient because it computes that kind of state machine for was pressed, was released, or is pressed during this tick. And this is very important to use because it's fully safe on predict rollback mode. It doesn't give false positives and that kind of thing. And it's very important for the gameplay field to be correct on every single game client. And I'll do something bad here, but it's just for the sake of the demo. So I'm gonna add kind of like a big data structure here, which is not the, let's say, the final recommended way to do this. So there are several examples and documentations on how to do better compressed input so you do not use a lot of bandwidth. So a recommendation is actually to do something like bytes and encode the data you need into bytes, like by an angle that you're moving with and so on. But I'll be a bit simpler here, and I'll just add a 2D vector, and I'll call that the direction I want to move towards. Notice that I'm using a special type here called FP vector 2. Quantum uses fixed point numbers to replace floats because these are fully cross-platform deterministic, so you will never use floats in the simulation. If you use floats, this will lead to the sinks, so never use floats. We do not even allow you to specify data structures with floats in the DSL files, although we allow you that to be used on systems, but do not, never use floats. Use integers, longs, or the special types we give, like FP vectors, quaternions. We have a full math library for you to use for that. So that's it. When we build this solution, it comes with some pre-build and post-build tasks, and in the pre-build tasks, Quantum will run its compiler that will convert these DSL files into actual C# types with memory alignment and everything that's needed to guarantee cross-platform determinism. But in this case here, we'll not even take a look at that. I just want to know that, yeah, I have an input struct defined already. So next thing I'm gonna do is I'm gonna create a system. So finally, we're gonna create a system. So this will be a regular C# class, and I'll call it Movement System. So just do that. That's a regular C# class. I'll just fix a few things. I'll put it in the Quantum namespace that's required for now. And I know I'm gonna be using pointers because that's the bread and butter of Quantum. It's using pointers for speed, modify data in place as much as possible. And I'm gonna make this a special kind of system that will extend what we call a system main thread filter, which requires a type for the filter struct we're gonna use. So a filter struct, it defines what is let's say the archetype, if you think about that, of the entities that you are interested to update with this system. So you define, okay, I'm interested in the filter, in the structs, in the entities that have this collection of components. So this is what filter struct means. So I'm going to create here a struct. I'll call it filter. So there is a specific structure you have to add to these filter structs. As I said, this is also documented on the components entry in the menu that I pointed to, but I'll just go ahead and do it here. So an entity is defined by the type called entity ref, or reference to an entity, and I'll call it entity. So it's mandatory that a filter struct has this guy. So it has to have one property that has the type entity ref. And then you define the component types you are interested in. So in my case, I'm interested in entities that have a character controller. So for now, that's the only thing I'm interested in. So I'm just going to add here CharacterController3D. And very, very important, you say you add it as a pointer. So I'll call it KCC, Kinematic Character Controller. For now, I'm only interested in this, but I'm also gonna add here. These guys always have a transform, and I want to be able to rotate the character. So I'll also say I'm interested in the transform of this entity. So property name will be transform, and the type will be this. And then this lets me add the filter struct directly here. It is tied to the system type. So here it is. It complains that it's not implementing a method that this defines, and here is the method. So here's what this means. I'm saying that the system is interested in the entities that have this, let's say, this layout. They have a character controller and a transform. Notice that they can have other components. I'm just saying that every single entity that has at least these two will be filtered, and we'll be updating them here. And this is a very convenient kind of system because the update method here will be conveniently called already for each one of the entities individually. So you don't have to do any loop or anything. You already receive the entity itself here. And so how do we actually apply gameplay input done by the player to this to these entities that we're interested in here? So this is what we're going to do. So everything in quantum simulation revolves around frames. So a frame is the representation of your game state. And what the simulation does is you'll be updating the data about the game state every tick or every frame. And all you need to update the frame will be accessible through the frame itself, creating entities, modifying entities, or getting the delta time, or being able to grab references to assets that like nav mesh or terrains or other things that are part of the static data that you do not modify but you actually can read from and update stuff. This will all be accessible through frame. Physics engine doing queries, raycasts, everything is done through frame. And not different than anything, also getting access to player input and other data about the players who are connected and not, it's all accessed through the frame. So in our base case here, what we're going to do is we're not making this yet multiplayer, so this will be next as soon as we have it moving. So I'm just getting the input for a single player. So that's the only thing I'm interested in now. So it's the first player. I'm getting the input. And if you remember, we defined the data structure for input here in this QTN file. So what does it come with it here? So I'm getting a pointer to this struct that represents the input of the first player, and it comes here already with a jump button and with a directional vector. So what we're going to do here is we'll just directly operate on the KCC that we got from this filter struct that we got here. So our KCC has very convenient methods for jumping and moving. You can read more about what these mean and how you modify those things in the manual entry about KCC, but here it is. Notice that the API requires you to pass the frame, and then you might want to define if you want to ignore the grounded state of the character controller or not. I'm not going to ignore him. I just wanted to jump if it is already grounded. But what you need to, we'll do this only on the first tick where a button is pressed. So the jump button is pressed. So I'll check this. So if the jump button was pressed on this frame, we're gonna jump, and that's it. Notice that was released, it also exists, and is down also exists for you to, if you need to use that. But here's what we actually need. So this is what we're gonna use here. So you're gonna jump the character if the button was pressed. The KCC itself computes grounded state, and you will only do this one time, and next frame you will not be able to do again, so you don't do double jumps unless you code it to do that kind of thing. We'll also use the other method in the KCC called move, which is a simplified way of moving the character around. And you see that what you pass in is always frame. You need to tell the KCC who is self, who is the entity that you. So because components do not know which entities they belong to, so this is required here. So you pass the entity that represents self of this character controller, and then the last mandatory data you have to pass is the direction you're interested in moving towards. So that will be our input direction. Did I miss anything here? Okay, it's because I need it to be 3D, so sorry about that. So we'll convert from a 2D vector to the XZ coordinates in 3D, and that's it. That's what's required to move. I'll do a couple of things that are interesting here. So first, Quantum is it's notoriously for protecting your game against cheating, and this is one of the interesting things. So it's impossible to do speed hacks in Quantum if you're careful with this, because Quantum is simulation authoritative. So what I'll do here is an interesting thing. So I'll check if the player actually attempted to do something like a hack, which is if the magnitude or squared magnitude of his direction input he sent, because we're still naively using a vector instead of an angle, if he tried to send, let's say, a bigger vector to try to move faster, we'll fix his attempt just by normalizing this vector. So there is no way he can send a vector that's larger than 1 in size. So that fixes it, and so this is speed hack protection. Because this will be running on every single machine, even if the guy tries to send a bigger vector, you will never be able to move faster, because this fixes it in every single client. So he will never affect what other person sees on screen at all, because the game is simulation authoritative. So that's it for moving, but we need to do one more thing, which is the KCC does not rotate the character itself. So to do that, we'll modify the transform directly we're gonna make the rotation of the character be, so we can do fp quaternion dot look rotation. There are several ways to do this. We have both the Unity style and the Unreal style implementation of look rotation, but you just say, what is your forward vector? What is your intended direction? Notice that this vector is already expected to be either normalized or close to normalized. So we can send this, but an important thing here is I want to make sure that we do not rotate the character if he did not send anything. If he's not trying to move, we're not gonna rotate the character, because this would lead to wrong math. So that's it. I mean, I took a long time because I was explaining everything I was doing here, but this is all we need to do. Nice move, let's say a nice starting code that moves a character around. So we're fixing against speed hacks, we're jumping, we're telling the character controller to move, and we have a direction to move. If you go now and compile this, it will build the DLLs, inject on Unity. When we move to Unity, Unity needs to update itself because we have a new DLL for the simulation side. And oh, I always make this mistake. Nothing will change. If I run here, it will not yet run the KCC. I will explain why, but I'll do it anyway so you guys see. Yeah, the KCC is still not following. So what is going on here? So I always forget this. So when you create a new system, Quantum is not gonna automatically get it. So there is this class here called System Setup that lets you define which systems you want Quantum to run. I'll do a few things here. First, I'm gonna remove stuff that's related to 2D because I do not need it. And other thing is, yes, I'm gonna add my movement system here. Okay, now, so this is the order in which Quantum is gonna create the tasks in the task system. So you will run these systems in order. And yes, you can do parallel tasks inside your systems as well, but this is way advanced and we're not gonna touch this in this video. But building again, so running now, we shall finally have our character falling. It will not yet move. We'll get to that point. But if we press play now, the character finally falls to the ground, and it's not going through, falling through. A few other things I want to fix here and take the time to show you a couple of interesting aspects of Quantum. So you see that these boxes are rotating a bit. The thing is that although they are individually allowed to sleep, which is, so if you see here in the configuration, they are allowed to sleep. So they could go to rest, but I think by default, if you go to this resources DB configs here, this special asset called simulation config, it lets you even tell Quantum how many threads it should use. So for PC, it's nice to use 4 threads, for example. It gets you more performance out of it. But it lets you configure a few things about the way Quantum handles memory for entities, but especially the physics engine, fully configurable things and navigation and so on. So by default, it doesn't come with this setting turned on. So it was not allowed. So entities were not allowed to go to sleep at all. So if you press play again now, you see that these characters become gray, these boxes become gray because they're now sleeping. So they're not taking any time on the physics engine because they take a lot less CPU from the physics engine when they're put to rest. They can be awakened either by a collision or by code. Couple of interesting things on this topic here. So documentation-wise, there is an interesting entry that I can point to about configuration files. So it explains you a few things about how Quantum starts the game, especially running online, and how all these config files, what they mean, and each one of the configurations in them. So there's an entry here about simulation config that it's nice for you to take a look at. So enough. So our character is not moving yet. Why? Because in Quantum, we do have this data structure that we created here to represent the input intention, and our system is actually using that to move the character. But we're not setting this input from anywhere. So how do we do that? So we have to go back to Unity and understand that Unity runs as a view, but Unity has another very important role, which is, we know that we also do the level design on Unity, and everything is done data-driven from here by drag and dropping and placing things. But the other important role of Unity, besides rendering and UI, is injecting input to the Quantum simulation. So you notice that this is standard game scene comes with this local input game object that comes with this script called local input. Let's open it into second instance of Rider. That will be for the Unity side of the project. So you see that this script comes predefined by, it does subscribe correctly to the Quantum related callback for polling input, which is what Quantum calls to say, hey, I need now for this particular frame, I need the input for this particular player because this player is controlled by this machine. So this goes a long way because Quantum does allow you to play the game, play with multiple players from each instance of the game itself. But for now, what is important here is we have this input struct that we can set data to. And what we'll do here is you see that this is exactly the same struct that we have that will be consumed on the Quantum side to run the simulation. So we have two data to set here. First one, I'm going to do the jump. So this is very important. Always pull from this function here and always set exactly what is the current state of the whatever is the framework you're using for input. I'm going to use here the standard Unity input, but you can use the new input system from Unity. You can use rewired, anything you fancy. But in this case, I'm going to use Unity engine.input.get button. So notice I will not get button down or get button up because those only exist for one Unity frame and you can have misses here. You exactly set the exact state at the time of the call. I will not set direction yet. I'll just test with this to see what happens. So I have a jump, so we should be able to jump the character having this. So here it is. Let me start. So if I press space, yay, our guy can jump. Notice that the jump is not high enough. So let's play a bit with the configuration file for the one that we're assigning for this particular character controller. You can have as many configurations as you want, but I'm going to play with this one. So you see that the base jump impulse is 2. Let's make this 4. Notice that the game is still playing. And now the jump impulse is higher. This is a cool thing about most of these configuration files. You can just modify them with the game running and you immediately have the effect of them. Not everything works like this. For example, data that you define on a component prototype, which is part of the entity prototype that you create on as Unity prefabs, etc. Those, they are initialized when you bake data, which is automatically done on when you press play or save the scene. You can configure that, but you cannot change data directly inside the entities from the Unity side live. That's not possible to do. You can only inject the input and modify from systems. But data that's about these static assets, you can modify on the fly. You can only do this on local games, right? If you're running online and modify this, you'll get a desync because the other machine will not have the same modification at the same time, but it's fine to do this directly here when playtesting from a single machine. So I'm still jumping here with the higher thing. And an interesting thing to show now is there is an interesting thing in Quantum called State Inspector that lets you actually see all the values from each one of the entities that you have in the game. So these two entities, 1 and 2 here, are actually our boxes. And you notice that they have a transform physics collider and a physics body. The other component is the one that lets the view updater links them to the game object that is the view for them on the Unity. Then we have our component, our entity that has, besides the collider, it has a character controller instead of a kinematic body. And the thing is, you can always open the data and you see that's exactly where they are and exactly what is the see, notice that the tick thing, the game is still running here, and see the transform here that I opened about the entity that represents the character that we are controlling. So take a look at the position and rotation. Rotation is not going to change, but as I jump, you see that the transform values are changing as it is. So this is a live view of all the data about the quantum game state that you can always have around to see how things work. So I'll stop here so we can finish the movement code so we can move this guy around. So next thing we have to do is we have to fill the vector. So what I'm going to do is I'm going to copy two Unity axes. So So I'll create a variable for x here, and I'll use the get axis input for the horizontal. I'm just using the standard Unity defined axis. You guys know this for every basic Unity tutorial. And so I'm gonna get vertical. And what I'm gonna do now is I'm gonna set on input.direction the vector we get from these two axes. We know that it goes from -1, 1, so I'm just gonna create a vector out of those. And there are a few ways to do this, but I'm gonna do a unity vector 2 out of xy, and it conveniently has a 2 quantum FP vector 2 that you can use. The important thing about this is that this is using conversion from float number to fixed point number. This is fine to be done here because you're on the Unity side injecting input from this machine, and this input after the conversion is the same value used on every single one of the machines that run the game. So this is safe. You cannot do this kind of thing, converting from float stuff to fixed point stuff inside the simulation. But when injecting input, that's fine. That's actually the way to do. So that's all we had to add. So we added the directional input here. Notice that I don't have to care about the size of this vector. Let the hackers try to modify this. This is fine because the simulation itself fixes it on every single machine. So it's a self-auditing code that self-validates everything on the other player's machine. So there's no way someone can try to cheat. So now you see I can move around and rotate. So where is the? I think I had to choose. So Z is there. Let me see if it's it's correct. So I move left, I move right, and notice that even the rotation is already correct. So all good. Cool. So last thing I want to do here is to demonstrate to you guys how to run. So let me see here. So the video is already 46 minutes long. Yeah, let's get to the 1 hour mark. But it will be 1 hour, and we'll have this thing running in multiplayer the correct way to do it. So let's now add something nice. Let's create a component. In Quantum, entities have technically no relation to players. Entities are these independent things, while you have players in the game, but they are not technically related to entities and components. They're not related to each other in any way. You see that I have this hard-coded 0 here. Every time you see a number in the simulation, in the code, this is bad smell, right? So this is something like, this looks hard-coded, this is bad. So the right way to do this is, okay, let's create a custom component that lets us create entities and tell in a component that yes, these entities are controlled by a player. And by the way, here's the player number that does it. So the player index that represents that player. So we'll create a component. I'll call it player link. It's a common name we use internally for this particular let's say functionality when you write a game simple or something. And we have this special type again called player ref, and that's all you have to do to represent a player. So we have this component now. I can actually go and build this. I'm gonna see. I'm not sure. Yeah, we'll build. So I made this first build so it generates the files. I could have coded already anyway, but and now I'll modify my filter here on my system. In that I'm also interested. So these entities not only have to have character control and transform, but they have to be controlled by a player. So I'm interested in those, not NPCs, but actually entities that are controlled by a player. And so I'll call it link. So to represent the player link. And the only thing that this is changing for me is that instead of getting the input from player 0, I now know that the filter guarantees me that these guys have the component player link. And I just pass the player ref. And bang, our hard-coded player index is gone, and we can trust we can run the game like this. And I'll press play here. This is going to break the game first time. I'm going to explain why. Because the interesting thing about player ref is that if you don't set a value to it, it will be as a 0, which represents a non-existing player. In terms of index, this becomes a -1, but internally here is a 0 as a player ref. This is explained on there is an entry in the manual about player. So if you see here, it explains what is a player index, what is a player ref, the relation between those, and all the things related to this concept. You should, as always, you should read the full manual, but this is the basics of it. And okay, this is the modification I had to do in this part of the code. And we'll have to modify our our character in the scene, because originally it doesn't have, so this guy here, it doesn't have that new component. So if I press play here, what will happen now is nothing is going to break, but the thing is there is no entity that qualifies as having all those components. So what happened is that our guy is not moving at all anymore. Remember, it's not even having gravity applied. Why is that? Because it doesn't match the filter anymore. So we have to add that component to it. So you go here to the entity prototype Unity script, and you can add also custom components that you created. Notice that it will show up in here now. So by adding the player link, you can let, even from here, I can assign it, okay, it's going to be the first player. By default, Quantum comes predefined for up to 6 players. Technically, you can go up to 64 by adding a pragma. This is also documented there. You guys can see this being discussed several times. So I'm going to say, hey, this guy is controlled by the first player here. And if I run now, yay, now it's moving again and moving with, it's correctly moving as expected. So one thing that's annoying me here, let me orient this camera so I can see it better. I'll make it a bit like a top-down camera from here. Okay, that's fine. Should be fine for seeing. Okay, let's remove the gizmos. I don't need, oh, the gizmos are nice in this case. Just rambling. Okay, so yeah, that's fine, but I promised that we were gonna run this online. I'm just taking my time to actually do it the right way. So yes, I'm placing a thing, but normally you want players to create their entities, the entities that represent them as they join the game, and then they start moving or doing that. So how do we do that? So welcome to another API on Quantum. Let me see where that's done. So you have this thing called, in the same documentation entry, you have this entry called RuntimePlayer that explains this special class called RuntimePlayer that you can optionally send when you join a game, and that will let you add any kind of data you want here. And you see that the example already tells about like the character spec the player chose to play with, and conveniently there will be a callback on the simulation that will signal to us when someone sent this. So this is what we're going to use to actually instantiate the player entities on the fly instead of actually relying it to already exist on the scene. So this is the last modification we're going to do, and then we'll be able to just play the game online. So to do that, we'll get to this very class called RuntimeConfig, and we're going to use another interesting aspect of entity prototypes, which is instead of instantiating them directly from the scene, we're going to grab the entity prototype that was defined on Unity but actually instantiate it by code. And to be able to do that, we'll have entity prototype asset ref, so a reference to an entity prototype here, and I'll call that character prototype. So that would be what I'll call it here. An interesting thing is we need, if you see here in the manual, when you add RuntimePlayer, you must add this partial implementation of the serializer, because you're defining this is a class, so the serializer is not automatically created by Quantum in this case. So we need to serialize the data about this thing we added here. So the character prototype, in this case, we only need to serialize its ID. So it's just the ID of the prototype. It will be the same on all machines that we need to serialize. That's what we need for RuntimePlayer, the class itself. Then comes the interesting part. So we'll make our system here react to when a player sends its data about his RuntimePlayer data. So this is the signal name, iSignal on player dataset. I didn't mention what signals are, right? So signals are these special callbacks that are used for inter-system communication. It's a pub-sub API for the simulation itself, and we use this for collision callbacks, for nav mesh callbacks, for player dataset, and a few other situations. But you can also define manual signals yourself, signals you define. And there is, as always, there is an entry about them here in systems in ECS. So there is an explanation about how you can define signals yourself. So let's go back to code here. So we need to, because they are defined as interfaces, so we have to implement the signal itself. So here it is. So every time a player sends its RuntimePlayer data, we'll have this callback called. And as always, you receive frame, so we know exactly in which tick this was received, and this will be the same in every single machine. So what we'll do here is, let's get the data that was sent. So what we need is, again, everything comes from frame, so get player data. This will give us the copy of the RuntimePlayer class. Oh, I made a mistake here. Sorry guys, I implemented this on RuntimeConfig. RuntimeConfig is for the whole game. It's the same idea, but for the whole game. I should have added this to RuntimePlayer instead, so I'm very, very sorry. It even comes with the serialized user already in here. I'll just paste here. That's what I actually meant. So anyway, coming back to the signal here. So when we have on player dataset call for this player, we can retrieve the data that he sent here. So data will have the character prototype he sent. And so going back to the beginning of the video, I talked about like the entity prototypes, and there's a manual entry that explains that. So what he sent is the ID, and so we have this ID about an entity prototype ref. So how can we create an entity out of that? So the way to do that is we can retrieve what the prototype object is by, again, everything is accessed by frame. So this is done by find asset. So and it will be of the type entity prototype, and all we have to pass is data dot character prototype dot ID. Same thing that we serialized. So this lets us retrieve the actual object that represents the prototype. And to instantiate the actual entity, you just do frame dot create. It has an overload that receives an entity prototype. That's it. The entity is instantiated. But we have to do a couple more things. I'm interested to. I want to make sure the characters are not instantiated in the same location for different players. So I'm gonna use the player index itself to offset the players, let's say on the x-axis. And the second thing, we have to make sure we assign the player ref to that component guy that we added, the component called player link. So we know that when this guy instantiates an entity, it will be from now on controlled by himself or herself. So let's do that. So the API for that is, I'll do it the safe way. So I'll do if frame.unsafe, I'm interested in pointers, dot try get pointer. I'm trying to guarantee that this thing has that component internally. So I'm trying to get pointer. What is the entity here? What is the entity? So interesting thing. Create returns the entity ref of the entity that just got created. So I just was not using it, but now I'll use. So for this entity that was just created, I'm interested to see is outva player link PL. So why is it complaining about try get pointer here? Oh yeah, sorry, I needed to specify the type for try get pointer. So player link. This is the generic method. So if this entity has the player link, I can now assign player to be player, the guy who instantiated this guy. Done. And similarly, let's get access to the transform in a clear way here. So transform 3D, it's the one that we're interested in. I'll call it T for now. And what we're notice that because I'm operating on pointers, I'm operating directly with the data in place. So Quantum ECS also has a get set for the whole component, but it's much more efficient to operate directly in the pointer. So that's what I personally always use. So transform has a position struct that has an X value. I'll use the value, the old other values I'll use as they come from the entity prototype, but I'll modify just X. I'll make sure X is player. Player is a player ref. How can I do that? Yeah, I can actually convert that to an int. So I'm just being lazy here. So if I do this, it already does a cast. So sue me. I'm being a bit lazy here in doing ugly code. Something for you guys to laugh. So that is it from the simulation side. So we're procedurally instantiating the entity prototype now, modifying some data in it besides the stuff that comes with the prototype accordingly, and our code here will work correctly. And with this, we'll be able to, instead of having that guy directly in the scene on the Unity side, we'll move it to be an actual entity prototype that we pass by code. And I will show you how to test on the gameplay scene and how to make this finally run online. So first thing, let's convert this entity thing as, I'll call it player character for now, and let's make it an actual prefab here. I can now delete it from the scene because I have the prefab for it. A few interesting, sometimes depending on the Unity version, when they change a few things, it's always safer if you make sure to, let's say, regenerate the Quantum asset database by pressing Quantum generate asset resources here. So this is guarantees that we have the links will work. But here's, it has the same structure. I could drag and drop it in the scene, but I'm interested in implementing this manually. So remember that in the code, we added to RuntimePlayer this property called CharacterPrototype. So in the test, in the scene when testing offline, you have this thing called the Quantum Debug Runner. You see that the Quantum Debug Runner has a container for a few things, and one of them is our player thing. It will never run the game with 0 players. It has at least 1 player. What this container is a container for player data. And when we have it here, so you see that this is the RuntimePlayer class, and it already adds us the slot here for us to drag and dropping an entity prototype assets. And conveniently, this is what we have by drag and dropping this. So this is it. Our test player will instantiate this just by drag and dropping it here because we prepared the code for this. So when we press play here, here is our character, and I can already move it around like before. Nothing changed. And an interesting thing, you can actually test Quantum with 2, 4 players, how many you want here locally as well. The thing is that the input polling will be called for every single one of the local players, in this case 3. So you see, we have now 3 characters, and I can control each one of them with the same controls because they're all local. So that's it for testing locally. Let's move to test online. How complicated that could be. So we'll move to our menu. So there are a couple things you need here. So first, this is for the Quantum runtime config. And the other one is you have this custom callbacks thing here. So if you see, this basic custom callback is a script that will react to quantum callbacks. So this is when running online, this is the object that will have a few functions called when quantum game starts. And you see here that it has a function for when the game is started and a function for when you get a snapshot for dropping into the game. You can do what you want in these cases, but the interesting part here is that we're actually sending a RuntimePlayer instance from here. And what I'm going to modify here is I'm going to make this RuntimePlayer instance for the local player player data. I'll make it public here so we can define the data from the Unity side like we did on the local for the local test. And here, instead of sending a new RuntimePlayer, I'll just send whatever we added here visually from the Unity editor. So this will let me, even in running online, set visually from here. And later on, of course, you guys are going to be making this be a character selection by the player and so on. But here it is. I can again drag and drop my entity prototype, and this is going to be the one that runs when run the game online. And the last thing we need here to make sure this game runs online is we need to set Photon to connect to a specific app ID, which is a concept by Photon. So this is not quantum specific, but we need to go to our dashboard and get an app ID for a quantum app. You guys can do that by, if you're a quantum customer, you can come here, create a quantum specific app ID, because this one will have the quantum plugin that runs the server side of quantum here. So I'll call it Quantum2 demo. Create a new app ID. Where's my Quantum2 demo? What happened? Here it is. Why didn't it go to this? I like this one here. So I'm copying the app ID here. And we'll go back to Unity and we'll just paste it here. That's it. We'll quickly test it online here. So this quantum menu, thanks Jonas, my colleague here. So this was written by him to very conveniently let you pick up a nickname and play with any of the available regions for quantum. I'm playing in Europe, which is closest to me here, and also lets you segregate players into different lobbies by choosing these different app versions here. So you can very quickly set up tests with your in development and even with players and so on. So it's very convenient. You will join a room, and if the room still has enough slots and so on, you'll be able to do it. So let's press play here. You see that it lets you limit the number of clients that can connect. You can also, it's a bit dark here, but you can set it to be not possible to join anymore as the game starts, but that's not the default option. It actually lets you. And you know how many are currently connected. You will see their nicknames in this list here. And when you press start, this is actually going to start the quantum game, and quantum is automatically going to switch to the game scene. This is an optional feature. You can read about how to disabling it. So let's go ahead and do it. Here it is. So this is actually running online. It's not yet interesting enough because we do not have two game clients running. So to properly test this and prove that this is actually running online correctly, let's make a build. I'll just make sure I have, I don't want to do an IL to CPP build, although this is the recommended thing for production and actual testing, but just a quick test here, it's fine to do a mono build. So I will create a new folder here for a quantum demo. So this is the folder, select, let's wait for the build to finish. Should be short, just a mono build. Should be fast. And we'll test and see how it goes. The camera is bad, right? So I should have changed the camera. So I think I'll be able to demonstrate anyway. The camera is inverted, so it will be a bit difficult for me to control here from the keyboard, but that's not a problem. Let's just quickly test this here. Oh, damn. I forgot to make it window by default and make it resizable so that, okay, let me see. Should we test against the editor or should we build again? I mean, this video is already so long that I'll just do two things. I'll fix the camera and build again. So first, let's make the camera slightly more, and yeah, I still want to keep this stat so you guys see a couple of interesting things, but I'm gonna make the camera be a little bit easier to see the game. So align with view. I think it's actually safe to do something like this because these boxes will fall. So let's test quickly here before committing to a build. Yeah, this will be enough to see. Yeah, that's okay. That's not. It's a bit too light, right? So let's change a bit the lighting. This should be easier to let us see what's going on. Yeah, this is a bit nicer. Cool. That should do it. So just save, quickly save, build again, and then we'll, oh, almost forgot. Let's make this windowed with a small window. That's nicer. So I'll be able to position a few builds side by side, and then we see what happens. Live video, so no editing at all. So it's opening in the second window here, but I'll just drag them to the side. I'll test with 3 already now that we have small enough window size. So it actually lets me use the same nickname everywhere. It's as long as we're in the same, it's not gonna clash that. So I can have people with the same nickname. I'll just make all of them. You know what? Yeah, if I late join, I'm gonna do a disconnect and reconnect so you guys can see. But I'm not. Yeah, let's just start testing. So pressing play here, here it is in sync game scene, and I'm controlling that guy there, and you see that it's moving, and you see it moving every single one of the screens with almost. It's pretty much impossible to notice any lag or anything like that. So. Which one is the one that yeah, that one. So I can control now this guy. So this got the first one, and this guy controls the other one. Yes, that was it. And you see the stats on each one of them. So you see how many ticks of prediction you're running and everything, and you see that games is fully in sync. A cool thing about Quantum is that Quantum 2 is that it handles snapshot late joins for you automatically. So if you disconnect with one of these guys and reconnect, it will actually grab a snapshot and reconnect back. And I didn't do exactly everything that you do on a game. Like if I disconnect here, my entity will still exist. So this entity that I'm controlling here, the one on the right, will still be in the game. It will just not be moving anymore because my player is not sending input anymore. You could detect the disconnection and actually destroy the entity if you wanted to. And when you join back, you could recreate it. If I join with a fourth game client here, it will be able to join. It will just not create an entity to it because our code here, when we join waiting for a snapshot, which is what happens in a drop-in, will not send the RuntimePlayer data. And we do not send the RuntimePlayer data when we detect that we actually late joined, which is what happened when you get this here. So, but we can just create a new instance here, and you will be able to connect to the same game. You will just watch the game. You will just not be able to play because you will not have an entity instantiated to it. So I'm not controlling any from this particular one, but I still connected to the same game. You guys can see that. But the cool thing, so I'll put this guy out. This guy doesn't matter. But I'm not destroying as well. So if I disconnect from this one here, you see that its entities is still there, and I'm not sure if I'm gonna be assigned the same player index here. I could have guaranteed that. Yeah, I didn't. I forgot to add that. So sorry, I didn't demonstrate this. But this could have worked if I eventually add enough guys. One of them is gonna be assigned eventually that player index, and he's gonna regain control of that. But the thing is that in Quantum you can tell the server an affinity. Hey, if possible, I want to try to control the same player index as before, and you do that by sending the connection GUID. It's something, it's documented in the menu and everything, but I just didn't code that. So I think when we add the sixth client connected here, it will finally get the one that's still reserved for the original GUID that the original player had. So, oh yeah, I finally got it because we had two, and this is finally gave me control of that entity back. So you could have we could have forced the exact same client to regain control by using the affinity thing. But yeah, this is, oh, sorry about that. The games are all still running, so it's all here. And that's it for the video. You guys can ask questions on Discord, check the other samples, and see what you do. So thanks for watching. That was it.